Great pleasure to introduce Tom Harris, who's going to tell you a bunch of things about climate change you probably won't read in the newspapers.
Well, thank you, Guy, and good morning, ladies and gentlemen. I must say I'm certainly pleased to have the opportunity to speak with you today. I think it's crucially important that everybody hear about a range of opinions on the climate change issue. After all, hundreds of billions of dollars are being spent all over the world based on just one hypothesis. And the hypothesis is that human carbon dioxide, greenhouse gases, that's the major one, at least with respect to human emissions, that is causing dangerous global warming. Okay, they're not looking at all the other theories. They're just looking at one theory, and they're banking or they're risking hundreds of billions of dollars on that. So throughout the whole debate, we should be constantly keeping an open mind that our foundation could indeed be wrong, because science always advances. Some people say the science is settled. Well, you might say that the science of plate tectonics is settled. Okay, we know, generally speaking, how the plates move, although there's always refinements, of course. But you'll see in my presentation today that the science of climate change is anything but settled. Let's take clouds, for example. Clouds. Now, it was only a few years ago that we thought that clouds were a net warming agent to the Earth. And that's what this graph shows here. Over here, this progresses from left to right, is actually time. Okay, so these are the old models to show what clouds did on average to the Earth. And these are the newer models. In the early days, it was expected that clouds warmed the Earth, because if you think about it, clouds, like water vapor, are a greenhouse gas. So that as the Earth got warmer, more water would evaporate, there'd be more clouds, more greenhouse gas, the Earth would get warmer. So this was a positive feedback time period. It's only about 10 years ago we thought that clouds helped warm the Earth. But more recently, they've found that clouds are so bright that they reflect most of the incident sunlight back off into space. And so now, if you take the two effects, the cooling effect because the clouds reflect sunlight, and the warming effect because they're a greenhouse gas, we're ending up with the most recent computer models showing a net cooling, okay? Now, this is supposedly settled science, okay? This is kind of ridiculous. If you think about it, they've not only changed magnitude, they've actually changed sign. What is, in fact, a natural agent that is responsible for more than 10 times all human impact combined? We've changed sign from a net warmer to a net cooler. So this just gives you a glimpse as to how the science is not settled. Okay, the science is all over the board. I just saw a paper the other day saying, why isn't it getting warmer in the last 6-7 years? It's supposed to be getting warmer. CO2 is being pumped out by China like crazy, but the temperature's stabilized. Some people even say it's dropping a little bit. Oh, well, they have all kinds of theories. They say, oh, it's still global warming. It's just interrupted warming. In other words, cooling. But the bottom line is the science is very, very far from being settled, okay? And we'll see in today's presentation some of the ideas as to what might be driving climate change, but we really just don't know. And in fact, we're going to talk about several things in the presentation. We're going to talk about a historical overview of what's called negative discovery. Negative discovery means, and this is something that people experience throughout their whole lives, the more you learn about something, the more you realize you don't know. You take a typical high school graduate going to university, they got an A+ in physics, they know what's going on. They enter into school and they find out they don't know much at all. Then they finally go through university and graduate thinking they know lots about physics. And they go into a research lab and they find they know almost nothing at all. And it goes like that throughout your life. The more you learn about something this complex, the more you realize you simply don't know. So we're going to give an historical overview of negative discovery and give you an example in history as to another case where this applied. We're going to talk about the vast uncertainty in today's climate science, and I just gave you a taste of it with the clouds. We're going to say, what does drive climate change? Maybe it's carbon dioxide, maybe it's the sun, we don't really know, but we'll talk about that. And finally, we'll ask, what should we do? It's not often that you can turn a runaway train around in 5 minutes, okay? So even if the science of climate change that they're using to base those hundreds of billions of dollars on, even if that's totally wrong, we're not going to turn it around overnight. So what is a practical approach to how we should handle the climate file? And that's what we'll talk about at the end. Now, the example I wanted to take from history, actually, to show you about negative discovery is in a field called cartography. Okay, understanding maps of the world. This is the map of the world as it appeared. It was taught in all the monasteries in 1450. I'll just let you have a quick look at that. I don't know if you can see it very well. But it's actually upside down. Okay? In those days, they actually put north at the bottom of the map and south at the top. Now, it wasn't until this year, 1507, that we actually saw the first use of the word America on a map of the world. And if we zoom into this area here, we start to see something very interesting. Remember, this map was the absolute atlas of the day. It wasn't really very different from the Ptolemaic atlas of the ancient Greeks. Okay? For centuries, 6/7 of the world had been considered land. And there was just nothing else. I mean, there was nowhere else to put it. Okay? It couldn't be any other continents because the only 1/7 that was left over for ocean just couldn't include any continents. So the Europeans before 1450, actually before 1492, with Columbus, were very confident. They were arrogant. If you were a skeptic of this map, you were somehow, you were condemned. And you'll see later that many people, in fact, did not want to speak out as the new discoveries became found. But this is, as I say, this was taught in all the monasteries of Europe. This is the de facto atlas of the world. Now, this is the first map on which America appeared, 1507. And let's zoom into this region here, because you start to see a new word appearing on the atlases that was not there in the pre-Columbian time period. Right here. Look at this word. Can anybody read that? Yeah. Incognita. What does incognita mean?
Unknown.
Unknown, yeah. So they were learning more, but they realized, whoa, we don't really know very much. Look up here, there's another one. Terra something or other, incognita. All over the place, all kinds of incognitas. Dotted lines, we don't really know what's here, so we'll just draw a straight line. And in the legends at the top of the maps in this day, they had a new expression. It wasn't, this is the world. It said, all of the world that has been discovered up to this time. Okay? So the post-Columbians were in fact much more knowledgeable, but also much more humble. They realized that in comparison with what there was to know, they knew very, very little. And that actually had a big spin-off on society. It affected the sciences, the arts. It was a very healthy thing for Europe. It made them realize that some of their rigid old ideas as to what the world was like just might not be right. Now, Copernicus, of course, the timid canon, he was a canon in the Catholic Church, he developed his heliocentric theory of the universe. The universe, as they knew it, was just the solar system, with these stars that were just, holes through the celestial sphere. In those days, they felt that the Earth was the center of the universe as they knew it. He was able to show through his observations and calculations that, in fact, it was the sun. Now, he knew this 30 years before he announced it, because it was dangerous to be a skeptic in those days, okay? Just like with the previous maps, in the scientific field, taught by the churches, etc., it was, in fact, the Earth that was the center, immovable in the cosmos. Well, it wasn't until he was told that he was within days of dying that he finally decided it was safe to release his book. So he did. The legend is that he released it actually on his deathbed. And it caused such a fuss. Oh, man, you wouldn't believe it. 300 years later, Napoleon was touring Poland. I guess maybe that was an area he conquered. And he came to Copernicus' birthplace, and he was amazed that there was no statue, there was no sort of monument, there was nothing to commemorate one of the real founders of the scientific revolution. It's because 300 years later, the Catholic Church still hadn't forgiven him for completely turning their models of the universe upside down. So he was, in fact, very justified to be a timid skeptic, okay? Releasing things, oh, well, if I'm dead, well, what can they do? I don't know if they excommunicated him, but the bottom line is he waited until his life was pretty well over before he did what this next gentleman did during his life, okay? Galileo was a skeptic. He was also kind of an ornery guy. So he made a lot of enemies just simply because criticizing the Pope in a sarcastic sort of way wasn't the way to win friends in those days, that's for sure. But he saw that Jupiter was the center of revolution. He could see those 4 moons that later became named after him, the Galilean moon. So he was a skeptic who also was proven right. Newton was also a skeptic. A lot of people look on him as being the pillar of the scientific establishment. You know, he invented calculus and optics, and he was head of the Royal Society. He was part of the establishment. And yet, when you listen to what he says about science, later in his career, he said, towards the end of his life, he said, I don't know how I appear to the world, but to myself, I just seem to be a small boy, walking down the seashore, picking up the occasional beautiful pebble or stone, while the whole ocean of truth lays undiscovered before me. So Newton was humble, at least in that way. He recognized that he, as one of the greatest geniuses in history, actually knew practically nothing in comparison with what there was to know. Darwin, of course, was a skeptic that was thoroughly vilified during his life. He had the audacity to question, where did humans come from? Okay, that's a controversy that in some spheres is still happening today. Certainly, we're filling in the details, and a lot of Darwin's theories are being changed and tweaked. But he had a actually pretty miserable life, partly because his daughter died very young, and also because he was a skeptic who voiced his opinion. And generally speaking, although, as I say, science is evolving, we generally think that he was right. And of course, Einstein was the ultimate skeptic. He was even skeptical of himself. Clark's biography shows how Einstein was in a lot of self-doubt about many different things and completely changed his point of view. So that's what we should be prepared to do if we see new information. Okay, so you may not agree with me on my conclusions, but at least when I show you the information that's available, at least let's be like Einstein. Let's be open to the possibility that we could be wrong. Now, negative discovery is very healthy in society. Can anybody tell me what that is?
Collider.
Yeah, exactly. That's the Large Hadron Collider. Okay, it's in the border of Switzerland and France. They have a big circular track, and they're ramming lead ions and protons into each other at 99.99% the speed of light, trying to create conditions that existed at the beginning of the universe. Okay, so this is very exciting science, and it's stuff like, well, I'll let you read that phrase. This is at the top of their website. So these scientists are among the leaders in the world, yet they recognize that everything they know is about to change, okay? So this is a great example of negative discovery. It also expands into the space program. You remember in 1989 when the Voyager 2 spacecraft went by Neptune, and this is Neptune here, as taken by Voyager 2, the scientists said they were getting in information so quickly, it was like trying to drink from a fire hose. Great, this is great negative discovery, okay? There's no question about it. Learning what we don't know. So if that's the case with one of the simpler planets in our solar system, and the gas giants, generally speaking, are quite simple, what about the case of the Earth? This is enormously more complex than Neptune. I mean, we have oceans and clouds and rivers and mountains and streams and life. The Earth is an exceptionally complex system. And so we have to say, how on earth are we able to forecast climate for, let's say, half a century in the future, when we can't even forecast the movement of this cloud bank over the next week? The thermodynamics, fluid mechanics, heat transfer are so complex that we cannot forecast how that cloud bank is going to move over the next week. In fact, some people, like one of our advisors, and I'll be handing out one of our flyers here at the end, you can pick them up on the front table, Chris Essex at the University of Western Ontario, he says the climate problem is so complicated that many of the leaders in the world say that we will never solve the climate problem. That's something you might want to look up on the internet. If you do Essex and climate, you're going to see what we call him a climate realist. He's not a climate skeptic. He doesn't doubt that climate changes. Of course it changes all the time. He doesn't, he's not a denier, he's not an alarmist. He just says, wow, this is an incredibly complex field. And he's actually listed in our handout here as one of our advisors. I should just say a couple of words. Guy suggested I do this at the beginning, and I forgot. And that is to tell you a little bit about the International Climate Science Coalition. Our group was founded in 2007 by the New Zealand Climate Science Coalition. They had a somewhat different approach to the whole issue. They were trying to be science-based and trying to be non-partisan. In other words, they weren't being left or right. Unfortunately, right now, the climate debate has become very polarized. Generally, people on the left want to stop climate change, and people on the right say it's nonsense. And what happens, of course, is people don't want to abandon their intellectual fellow travelers, so nobody changes sides. And it just becomes like a big war. And so what the New Zealand Climate Science Coalition did is they said, look, this is science. I mean, what the climate's going to do in 50 years is not a conservative ideology. It's just science. And maybe we know, maybe we don't know. We have all kinds of indications. So they had an approach they considered nonpartisan. And so they wanted to see an international body representing them at the United Nations Conference in Bali. So they created the International Climate Science Coalition. Oh, this is a key point. Who are your funders? The CBC asks us this all the time. Can we pin you down to being funded by the evil oil industry? You know, if you think about it, if our point of view was for sale, if we were able to, if we would change our point of view based on who fund us, then that would suggest we were dishonest. And if we were dishonest, then why would they believe our answer to the question, who are your funders? So it's a bit of a silly question.